ER mapping. So we are going to map this ER model into corresponding relational schema diagram, for example. So let's take one by one these entities: employee, dependent, supplier, material, client, location. So each of these entity will become a relational schema. Sometimes some of these relationships, if they are many to many, become another relational schema. Okay, so if we have a multi-valued attribute, we're going to decompose that one into another new relational schema. Okay, so I already did this. So you have employee entity here, so it becomes a relational schema with all these attributes included, right? So this is how you could do it. Then I come to this point later. So in addition to all these attributes, it has another attribute coming from some different separate relational schema of its location. So that is when we are trying to map this relationship, that is one to many, right? So I'll come to that point when I map that. All right, now second one is the dependent. Employee has dependent, so this is one to many relationship. So the dependent, the weak entity dependent has a discriminator, that is first name and the last name, both of them are the discriminator. And then if you want to map this relationship, what you do is you get the primary key from the one side and put it in the many side, and then make all of them the primary key. So this is the discriminator of that weak entity, plus the primary key of the identifying entity becomes the primary key of this dependent relation, right? All three become the primary key. Now when it comes to the office location, you create the office location table. Nothing new there, all the attributes from that office location entity. Now the relationship between the employee and the office location, this is one to many. So you get the primary key of one side and put it in the many side. That's what I did here. So if it is a foreign key, you underline with a dotted line. If it is a primary key, we underline with the solid line. So, and it is better to display, it is better to show what is the relationship between this one and the other entity by using an arrow coming from the foreign key to the primary key of the referenced relation. Okay, so next one is project employee. Project employee is the map between this works for. I'm going to map this one. That relationship is a many to many. Definitely you're going to have a new relational schema for this relationship, and that relational schema has additional attributes. Those are these two attached to that relationship itself. That's why we have a project employee with the employee ID and the project ID being the primary key, and then we added those two additional attributes to that relational schema. Now this mapping schema has additional two attributes. So this employee ID is referring to the employee table, project ID is referring to the project table, that is another entity, that is project table, project ID and the project name, project ID being the primary key. Now we have the supplier. Supplier is nothing new other than all these attributes except this the category. So the supply category, right? So this one can be a multi-valued, and then this category is not a property of the supplier. Rather it's a property of the material, and then the material also has category, and then the supply is also has category. Why don't we get rid of one of these and then keep only one there, so that when you join these two, you can get the category anyway, right? So in the supply table, I get rid of this category attribute, and I have a supplier material table. Material table has the category, amount, unit price, and the reorder level. Now I have a mapping table for the supplier to the material. That is a many to many mapping here, supplier material. So you have a new mapping table with the supplier ID and the material ID being the composite key, right? This one is the material ID is referring to the material table, supplier ID is referring to the supplier table. Now this one is already mapped, this one, and this is, and this and this. Now what is remaining is this client, this relationship, and this relationship between the supplier and the material. So the supplier material we already built, And supplier project is a many to many relationship. Supplier to project is a many to many relationship. What we do is get the supplier and then the project to supplier is a many to many relationship. The primary keys being the supplier id plus the project id. Supplier id is referring to the supplier table, project id is referring to the project table. Now the client is connected to the project client id, project id. Client id is referring to the client, project id is referring to the project. So we can get that connection as well. And also client has a phone. Why don't we separate that one into two, client and then the client phones. All right, so that's how you map. Okay, now let's see whether these schemas are in our normal forms, right? Let's check the first normal form. If we have multivariate attributes, then that schema is not in the first normal form. We have multivariate attribute telephone numbers in those two entities, but we separated them already, supplier phone and the client phone, so that we don't have any multivariate attributes, so that this one is already in the first normal form. Let's check the second normal form. Second normal form says if we have a composite key, there should not be any attribute that is partially depending on the composite key, right? For example, this one does not have a composite key, so that there is no problem of second form normal form violation there, right? So let's continue. Whether we have composite keys, any other composite key, this one, let's consider this. So this has a client id, telephone number and type, right? We added additional attribute called type, and in this case the telephone number is always determining the type. So client id, telephone number is the composite key, and then this type is partially depending on that telephone number, so that this one is violating the second normal form. As the same way, this supplier phone is also violating the second normal form. What we can do here is we can separate this one into two and saying that remove this supplier id altogether and keep the telephone number and type as a separate table, and then remove type from this. Now this is going to be a phone type, table. So this phone number is referring to the phone number, right? So here as well, these both of them are referring to this phone number because the telephone numbers are listed here. And if you want to get the phone type, you have to definitely combine this table with this table to get the phone type. But if you think that this type is not going to be that much duplicate, you can ignore this type of decomposition and then keep the type here, right? So which is the most regular case in any organization, because they don't want to combine. Joining two different tables are costlier than keeping that one simple type variable in that table. But anyway, if you want to convert this one into the second normal form, that dependency we should eliminate, right? So we delete that one. Anything else that is violating the second normal form? So this dependent table, probably not. First name, last name may not determine the date of birth. For a given first and last name, there can be same first and last name, those are repeating, right? So we should not too much worry on that. So there is no partial dependency there either, right? So the project id does not determine the start date and the end date, because it must combine both of them to determine that start date and end date. Employee id is also must be there, so there is no partial dependency there. Now our schema is in second normal form. Let's see whether this one is in third normal form. Third normal form is like should not have transitive dependencies. Employee ID determines something, that something is determining something else, so the middle value is a non-prime attribute. Let's see whether we have that kind of things here. Employee ID determines the SIP, and then the SIP determines city. Alright, so in that case there is a transitive dependency, employee ID to SIP, SIP to city, same thing to the state as well, right? So what we can do here is we can separate this one into two different tables, something like this. This is called zip and this is city, this is state, and you can reduce one key from here, then you don't need to have these primary keys. Line. So zip code is the primary key. Zip code determines the city and the state, and now you don't need to include city here. You can delete this one, city and the state, and also you can remove city from this table, city from this table, state from this table, city from this table, and then the state from that one is okay. Wherever you have city, SIP, state, you can remove them and then only keep the SIP inside that table, right? Now when you want to get the complete office location, the disadvantage is previously if you know the location ID, you can get all the information of that particular office location, right? City, state, and the SIP. Now because of our normalization, to get into the third normal form, we decompose the office location table into two, right? It has only zip code now, and then the zip code is another primary key, is in another relation with all the city and the state. So when you want to get all the complete information, you have to combine this relation and this relation. That is a join operation. But if you find this join operation is costlier than the repetition, then you should not decompose this one into two, right? You can keep this city and the state here if that is not going to be a big problem for you, right? Normally city names and the state names are not changing, so it is safe to keep it in the original table as well, but that will introduce some repetitions, right? If you have zip only, and then the zip can be repeated but not the state and the city, right? That is because we decompose that one into two different tables, right? The street is going to be a repetition, but street, the same street number and the name can be available anywhere in the country, so that we cannot get it into the separate table. Now we don't have any multivalued attributes, we don't have any transitive dependencies, we don't have any partial dependencies, so that these tables, these relations are in third normal form, reducing all these redundancies, update anomalies, delete anomalies, and insert anomalies. Alright, so that concludes this example of converting a ER model to relational schema diagram.